Hey guys, this is Palgorithms. Welcome to my video. Today I'm gonna try some path following logics. Let's get going already. First idea is we have 2 points on the screen and we go from point 1 to point 2. Just a simple straight line. Nothing complex. I wrote this function to make a rectangle in any place and any angle that I need. Then I defined 2 points and a car, and the car is writing the line between the points. Here's the result, and it satisfied me at first, but I think it's pretty static. We need some turns and curves in the way. So let's have more than just 2 points on the screen. And that rectangle, which I'm gonna call it the car, is going to follow those points one by one. Here's the result, and I'm pretty happy with it so far. We can even add more points if needed. That's pretty cool. And the only problem is it doesn't turn as I want it to do. It just instantly turns to the direction it needs to be. What if we try to follow a curved line instead of straight lines? If you've seen the video about the curved lines I made, you may know what's going on. But if you don't worry about it. I'll explain it to you right now. The Bezier function is a function that gives you a curved line based on 4 different points. But beside that, the function that I'm gonna use is the Bezier point function. Let me tell you what that does. Just like the Bezier function, the first 4 parameters are the actual points. But the last parameter is how much I've traveled the line. And it's a value from 0 to 1. And it gives me the exact position that I am on the line. The only problem is it's one-dimensional, so I have to use it once for y-axis and once for x-axis. And this is what happens when we change the t-value smoothly. But we need the angle of rotation too. And this is the actual function that we need to get the angle in any position. I have no idea how it works, but it gives us the exact thing that we need. Just look at this smooth movement with the angle fixed to the line. Mwah. One of the cool parts is it works live. Like, I can move the line and it works perfectly fine. So awesome. Now I have to make multiple curved lines and make the car drive on each of them separately in order. Just look at this beautiful road and this car driving it exactly as it is. It's super satisfying, isn't it? Please tell me it is. It worked really good, but as you may realize, it's pretty hard to make roads like this. You know, it's not efficient. The other issue is we don't actually have full control on the speed of the car in any point that we want. Just as I said in that video, beside the Bezier function we have curve function, which acts really similar to the Bezier function with a little exceptions. The only thing we need to consider is it only goes from point 2 to point 3. And the way I'm gonna solve this problem is pretty simple. On the first step, the point 1 and 2 are the same, and on the last step, the point 3 and 4 are the same. And in this way we can add even more points without any limits. You can see we can actually control the speed too. If we get the points closer, it will slow down the car, and the more we get them far apart, it will speed up the car. That's enough for today. I guess that was a good way of understanding the path-following logics. I have a special thanks to you all watching this video this long. If you have any interesting ideas about how we can make this logic into an interesting game, you can comment down below, and I'll be pleased to use your ideas in my works. And as always, keep yourself hydrated. There we go. Oh, yeah. Peace. Bye.